Hello friends, welcome back. We have seen how to shift a function to the left, right, up and down. What do we mean by that? A player or an enemy or a game object need to follow that resultant path. Maybe it was moving in another path and we want it to follow some other path and keeping the structure of the path. Now let's move on and get some more idea. Right now we know shift to the left, shift to the right, shift to up, shift down. Now we are gonna get some other information, guys. Let us take to reflect. Okay, you want to reflect. Reflect means flip, you can say. Yeah, to reflect or to flip f of x about x-axis. Okay, you want to flip a function about x-axis, or you can say horizontal, vertically, then you can do that by using this method. You have to subtract or multiply by -1, you can say, or negate the function. That's it, f of x. To reflect f of x about y-axis, that means horizontally. Okay, you want to flip, then g of x is equal to, you have to negate the angle itself. F of -x you need to do. Let us take the example for that. We have seen the graph. We have here pi by 2, and here we have pi, and here we have 3 pi by 2, and here we have 2 pi, and we know that the graph is going to look, let us take, here it is 1, here it is -1, and the sine function graph will look something like this, right? Like this, right guys? Now let us take, we want to flip it around x-axis, then we have to subtract the function. Let us take the table. Let's make a table here so that we get an idea, right? The values we will get. Here we will have theta. If theta is 0, and we know that sine 0 is 0, sine pi by 2 we are going to get 1, sine pi we are going to get 0, sine 3 pi by 2, sine 3 pi by 2 we are going to get -1, and sine 2 pi we are going to get 0. Right guys, we know this already. And now we have here sine theta, that is our f of x, right? Sine theta is our f of x. Now here we have to do negate sine theta, that's it. Whatever the result we have, the function we have to negate. So what we are going to get means, we are going to get 0, -1, 0, 1 and 1. What is the meaning of minus? It is, you are telling that multiply by -1, that's it, multiply by -1. So which will flip. How the graph will look? X is 0, then on 90 degree, on pi by 2, the value of y is -1, so -1 is over here, and on pi x the y is 0, on 3 pi by 2 the y is 1, the function is 1, and on 2 pi it is 0, excuse me, this should be 0, so it is 0. And if you draw the graph, you can see that we have flipped the graph, right? We have flipped it. Previously, let us take the player or enemy will be moving in this path repeatedly. Now it is going to move in this path. So we have flipped it horizontally, guys. And very simple, we have already the code written, we just need to change it. So what we are going to do, here the sign is going to return, and this one I can say multiply by -1, I can say that is the same thing saying as minus, just saying negative. Both are same. So I can say minus, no problem there, because it just takes this value, whatever the result we get, and negates it. Okay, let us save and check out in Unity. And if I run the code, you can see that we got an angle 0, y is 0. On angle 90, y is -1. On angle 180, y is 0. On angle 270, y is 1. On angle 360, y is 0. Actually, we are calculating even -90, right? That is y is 1. That is not necessary over here, but that's okay. And if you want to flip around y-axis, then we have to do a little bit different, right? We have to negate the angle itself. Let's see that too. Let us see that also, no problem. Now here we have a table, and this time, guys, what we need to do, we need to negate the theta itself. 0, we have to give -π/2. We have to give -π. That flips, right? This one only will show you it already, the sign is flipped over here, right? -3π/2, -3π/2, and -2π, right? So what we need to do here in our code is, while passing the angle, instead of negating this function, whole function, we have to negate our angle. Every angle we have to give negative. And we can save and come back. Okay, clear this. Let me remove this last value, which is not necessary for us here. Okay, let me save and come back, and if I run the code, you will see the values on the screen. The values will be, here we are calculating sine of -θ, which helps us to horizontally flip, right? On 0 angle, we are getting the value 0. Okay. On 90, we are getting -1. On 180, we are getting the value 0. On 270, we are getting the value 1. On 360, we are getting the value 0. If I need to draw the graph, so we will be having here -π/2, and here let us take pi, that is -π. Here -3π/2, and maybe over here we will be having -2π. This side we will be having π/2 as usual, positive sign, and this will be pi, and this will be 3π/2, and this will be 2π. And hope you know the graph for sine theta is going to look like this, right? The graph for sine theta is going to look like this, and whereas okay, let me come back and just save this one and come back, just clear this and run the code. So we are going to get here -1 on minus, I should display here 90, should display here minus, right? It's showing wrong. Let's come back and change here only the angles to minus, and this one will be minus, and this one will be minus, and this is going to be 3π/2, and this one will be -2π. Okay, this one will be -2π. Okay, and let us check it out whether it is displaying minus or not. Okay, let me clear this and run the code. Yeah, we got 0, minus 90, minus 180, minus 270, minus 360, and we have the result available. So on minus 90 we have y is minus 1, and on minus 180 that is 0, on minus 270 we have the value 1, and on minus 360 we have the value 0, and we have a graph something like this. We have just flipped y-axis. This is how you are going to flip function, and whatever we are seeing here, generic formulas, those apply for every function. On almost all the functions they are going to apply. You can try for any other functions too. Now let us move on for the next part. If you want to stretch means scaling. Stretch f of x vertically. What you need to do is g of x is equal to constant times f of x. You have to multiply your function with a constant. That's it. To stretch f of x horizontally, what you need to do is g of x is equal to f of constant times x. You have to multiply inside. And let us take an example for that. Okay, we will be having a table. Let's take an example of this. Theta will be 0, then you will be having pi by 2, then you will be having pi, then you will be having 3 pi by 2, then you will be having 2 pi, and we know that sine theta is going to be 0, 1, 0, negative 1 and 0, right? And if you want to stretch vertically, let us take, I want to twice my sine function amplitude, then I just multiply it 2 into sine theta I will do. And what result we get? 0 into 2 is 0, 2 into 1 is 2, and 0 minus 1 into 2 is minus 2, and the result of last one is 0. And if you are drawing the graph, if you draw the graph, right, so here you will be having pi by 2. Let us take pi by 2, right, and this one will be pi, and this one will be 3 pi by 2, right, and this one will be 2 pi, and let's take this one is 1 and this one is 2, okay, and this one is negative 1, this one is negative 2, and if you draw the sine theta, okay, sine theta function is going to look, the graph is going to look something like this, right, something like this. Whereas if you draw 2 into sine theta, so first it will be 0, and next 2, next 0, next minus 2, next 0, right? And if you draw the graph, you are going to find something like this, and you can see that you have stretched the sine function vertically, right? You have scaled its amplitude. This is how you can stretch the functions horizontally or vertically. I hope you guys have understood how we manipulate. I want you people to try yourself for stretching horizontally. I hope you guys have clearly understood whatever I have explained. So I just gonna list out all the functions to make you remember. To shift f of x up by c units, what you need to do is g of x is going to be equal to f of x plus c. You need to add or subtract, right? Depends upon whether you want to shift up or down. So to shift f of x down by c units, what you need to do is g of x is equal to f of x minus c, you have to do, right? And after that, if you want to shift f of x left by c units, okay, c units, what you need to do is g of x is equal to f of x plus c. If you have to shift it left, then to shift f of x right by c units, then g of x is equal to f of x minus c, some constant, and to reflect or flip f of x about x-axis, g of x is equal to minus f of x, you have to do around about x-axis, and to reflect f of x about y-axis, g of x is equal to f of minus x, you have to do. To stretch stretch f of x, to stretch f of x vertically, then what you need to do, g of x is equal to some constant multiplied by f of x, you have to do. To stretch stretch f of x horizontally, then g of x is equal to f of constant times x, you have to work with. So these are the few useful functions which helps us to do a lot of stuffs while working with movement of the objects in codes. Please note down this one. Now remember that we are telling about shifting left, right, up, down. The meaning is that you are placing the object somewhere at the origin somewhere and making it move. Reflecting is just flipping, right? Scaling in the negative way, you can say. Then stretching, right? The stretching is maybe increasing the amplitude, and horizontally if you are stretching means you are increasing the frequency or decreasing the frequency, you can say. So very useful codes and formulas. I hope you guys have learned a lot about the functions now. How do you work with? I just want to give you a small information about rotation of or movement of an object in a rotational way. Now let us take an example of, we know already about sin theta and cos theta. I just want to repeat it a little bit, a small information I want to give you. Now let us take, you have an object somewhere here and it is rotating like this. It's a 1 unit, guys, -1 and -1. Let us take, you are increasing the, let me write a formula so that you get an idea. X is equal to cos of theta multiplied by frequency bracket close, multiplied by amplitude plus x pose or initial x position, you can say. Similarly, y is equal to sin theta multiplied by frequency bracket close, multiplied by amplitude plus y position. This is a useful stuff over here. Let us understand this little bit. If I just give x equal to cos theta, y equal to sin theta, and theta we just increase, right? We just say theta plus plus, right? theta, theta plus plus. We are increasing the theta, and just consider that frequency is just 1, frequency is 1, amplitude is also 1, x position and y position is 0. That means we will be having x equal to cos theta left, x equal to cos theta, y equal to sin theta, theta plus plus. What happens means your object will be rotating in a 1 unit circle. It will be rotating like this. It will be just rotating like this slowly based on the frame rate. Let us take, you want to rotate your object faster. You want to rotate it faster. Then we have to multiply it by frequency inside. I hope you remember when I have explained to stretch a function horizontally, there we multiply a constant inside to the x itself, which will make it a frequency, increase the frequency. So what happens if you say 2, then your circle will be rotating twice the faster. Then if you multiply by amplitude, if you multiply the amplitude in x and amplitude in y with the same value, amplitude in x is same, amplitude in y is same, then what happens means this radius you have increased actually. So your object will be circulating in this fashion, right? You have increased the amplitude. And it will be moving, of course, frequency is 2, you have told, let us take amplitude is 2, then it will be rotating like this, twice also faster, and the amplitude is increased. Normally, this whole thing is going to rotate, the object will be rotating with respect to the origin. If you want to rotate the object in somewhere else, you want to move this the source point around which the object is rotating somewhere else, then you will be adding the x position and y position. It depends whether you want to just move it in the x direction, source of x you want to change, or do you want to change the y source. If you want to change both, then you will be adding x position as well as y position. You just want to change the x position. Maybe you want the circle to be rotated around this source. Then you need not to apply the y. Y will be 0, and x position you can maybe give 100. Then the circle will be rotating over here. Okay, the object will be rotating over here. Maybe you want to rotate the object around this point. The object you want to rotate around this point. Then you have to add x as well as y. You have to add the x and y value so that the object will be rotating around here. And of course, I just wanted to give you a brief information about this formula, because definitely we will be seeing these things graphically when we make codes. Okay, when we will be working with code, you will get much more idea, guys. But at present, if you understand, it's much more better. Then definitely you will understand when we come in a graphical way, or when we make games, you will be getting a lot of idea. And if you want, you can try by yourself also. Put some numbers, theta and some numbers, and calculate the x and y, and check out the position of the object and how it will be rotating. Okay, guys, I think for this class this much is enough, guys. Thank you, guys. Thank you very much. Keep learning. See you in the next tutorial.